what's the parent for carboxylic acid? 4.8, right? And then what are we subtracting? So we have an electron withdrawing group right here, right? So that's just one carbon away. So minus 1, right? And then we also have another one that's 2 carbons away. This sulfur right here. So minus 0.5. Right? So we have a pKa of around 3.3. And then what's the other functional group? Yep, we have an amine here. There's actually 3 on this one, sorry. So you have your amine here. So what are we subtracting? We have 1 carbon away. We have this electron withdrawing group, right? So 10.6 minus 1 carbon away. And then also 1 carbon away, we also have this amine group, or this amide group right here. So we have 2 electron withdrawing groups that are 1 carbon away, so that's minus 4. And I'll post all these on Blackboard. So the pKa is pretty low, right? It's around 6.6. You're subtracting for these 2 electron withdrawing groups. And then what's the other ionizable functional group? There's one more. Yeah, so the amine right here, so we're 1 carbon away, and we have this electron withdrawing group, or it would just, even if it's just this benzene ring here, would be electron withdrawing. So it's not attached directly to the electron withdrawing group. So if it were, say, an aniline that was attached directly to the ring, then it would be minus 6. But because it's a carbon away, it's not an aniline anymore. So it's still just an amine, and then this group would be 1 carbon away, so it's minus 2. And then you also have this this amide that's also 1 carbon away, so that's also a minus 2. So in total, it would be 10.6 minus 4, so it would be around 6.6. So we're really looking at yeah, so when you look at carbonyls, so remember this is a carbonyl, that's considered an electron withdrawing group that's 1 carbon away. And then the last ionizable group is just your phenol right here, right? So this one we always just say is around 9. No estimations. Got it? So how about over here, the clopidogrel? What's our ionizable group? So the esters do not ionize. You have another amine, right? So we have an amine right here. So tertiary amine. So we're calculating the pKa of that amine group. What do we have? We have an electron withdrawing group that's 1 carbon away. So minus 2. What else? We also have this other one here that's 1 carbon away. And we also have another one here that's 1 carbon away. So this is a pretty low pKa.
How do we know if there's an electron or electron?
So I listed in one of the lecture slides what are electron withdrawing groups. So in general, for electron withdrawing groups, you're looking at anything that is an electron withdrawing atom. So oxygens, nitrogens, sulfurs you're looking for. So O, N, S. And you're also looking for things that have a lot of double bonds. So that's why we say if the carbonyl, right, has both the double bonds and the oxygen, so that's definitely electron withdrawing. And then aromatic rings too. So aromatic rings here would also be electron withdrawing. So in general, most of the time for drug molecules, what you're going to be looking for are, yeah, anything like an oxygen, a nitrogen, a halogen, sulfur, or rings that are aromatic rings.
Last week, I think I recall you said double bonds, they don't close or something? If it's connected to a double bond, it's benzene?
Right, so if you're calculating the pKa of something that is on the other side of a double bond, you wouldn't take into account conductive effects. So for example, I talked about it when we had a carboxylic acid that was attached to an aromatic ring. You would only take into account that aromatic ring, for example, but you wouldn't take into account these other functional groups that are also electron withdrawing. So once you get to something that is a double bond, you wouldn't go past that.
Okay. So the difference between this is that one is attached before double bond, this one is part of the benzene, right?
Right, so for these functional groups, so if we're just doing this amine again, right, we're calculating the effect of this electron withdrawing group, right? We have a ring structure, an aromatic ring, so that's an electron withdrawing group. We have another ring structure, another aromatic ring here, so we're accounting for that one. And then we also have this carbonyl. So this whole group here is an ester, but we're mostly looking at this carbonyl. So those are the three electron withdrawing groups we would subtract from the parent of this amine group. But this one in particular, the third thing that we want to account for is the fact that it's inside a ring, right? So this amine right here, it's inside a ring, so you would subtract 1 from that as well. It's inside a non-aromatic ring, so it's -1. So the pKa of this is pretty low, right? So how about the amphetamine? This one's a lot easier, right? So we just have an amine, and 2 carbons away, we have our aromatic ring. So this is just -1, right? Make sense?
Yeah.
Okay, how about this molecule? Easy one, right? There's no ionizable functional groups, so no pKa calculating. But you wish they were all like that? Okay, so atenolol. What's our ionizable group? Yep, so we have another amine, right? So what are we subtracting? Yep, so 2 carbons away, we have this hydroxyl group. -1. -1. And then we have another one, yeah, that's total -1.5. So then we have 3 carbons away, we have another one that's -0.5. So in total, we're doing 10.6 -1 -0.5, right? So the rules are once we get to something that's not a carbon-carbon single bond, we don't keep going past it. So in this molecule, once we get to this oxygen, we don't count anything that's past it, because that's not going through a carbon-carbon single bond. So we don't count anything on this side of the molecule. Does that make sense? So the amide is not an ionizable functional group. Yeah, so once you're looking at, remember that inductive effects are only through carbon-carbon single bonds. So when you're looking at anything counting for inductive effects. Once you get to something, if you're looking at the effects of anything on this ionizable group, the reason that we're subtracting things is because this is an electron withdrawing atom, and when it's doing its electron withdrawing function, it's going through all of these carbon-carbon bonds to have an effect on the ionizable group, which is your amine. So, yeah? Right, so again, this group here, this is an amide, right? And these do not ionize. So we wouldn't calculate the pKa for that. We're only looking at amines, carboxylic acids, that we would count inductive effects. And then again, inductive effects are only through carbon-carbon bonds. So again, when we're subtracting for this oxygen, we're taking into account that it's going to withdraw electrons through all these carbons. Yep, so minus 1.5 total. All right, so furosemide, what do we have there? We have a carboxylic acid, what do we subtract? Just 0.75, right? Stuck to an aromatic ring, and then that's it. We're done with that one. What else do we have? We have our sulfonamide, which we would just say 9 to 10. And then remember this group here is an aniline. And because there are a lot of substitutions on it, on this ring that the aniline is attached to, right? So this ring has lots of substitutions here and here and here. It's very difficult to estimate the pKa. I wouldn't give you this in an exam, in other words, so don't worry about that one. But that's why we're not really calculating this one. It becomes very, very low. All right, on to group 5. What do we have? Right. So for this one, we have a carboxylic acid, right? So carboxylic acid, we have 1, 2 carbons away, we have a hydroxyl group here, right? So what do we subtract for 2 carbons away for carboxylic acid? So minus 0.5. And then we have another hydroxyl group here, right? That's 4 carbons away, and that's too far, right? Yeah, so 0. So all we're subtracting is minus 0.5. So some of you also noticed, right? I heard in the audience that we also have an amine here, right? But remember I said to be careful with any nitrogens that are in aromatic rings. So I wouldn't ask you to estimate the pKa of something like that. Because it's in an aromatic ring, it's very difficult to estimate the pKa. We also have an amide, right? But that's not ionizable, right? So for this molecule, all we need to know is the carboxylic acid. For which one? Why we didn't account for? So the aromatic group is so far away that you wouldn't, this carboxylic acid would not feel the effects of anything that's past like 3 carbons away. So once we get to 1, 2, 3 carbons away, anything on this side of the molecule, it wouldn't feel, it's too far. So you only count something that's like within 3 carbons away. So how about for hydrochlorothiazide? So nitrogen's in aromatic rings. So if it's a nitrogen in an aromatic ring, that's when the pKa becomes very difficult to calculate because it's, you can calculate it, but you would have to calculate